This is rocket fuel. Well, not yet, but it could be. In my last video, I mentioned that astronauts might one day refuel their rockets on the moon, using nothing but ice and electricity. And the question I kept getting was, wait, can you really do that? Yes, you can do a version of it right now in your kitchen. I'll show you exactly how to split water into rocket fuel using stuff you probably have at home. Then we'll get into why this matters way beyond a fun kitchen demo, and at the end, we'll zoom into the atomic scale to see what's happening there. This glass contains hydrogen and oxygen, one of which has been fueling rockets since the space race. They're just stuck together right now as water. So in this video, we're gonna pull them apart. Now this is electrolysis, which literally means breaking apart using electricity, not to be confused with electrolysis, which is using electricity for hair removal. Now let's break up some water. Now a standard setup looks like this. Water with an electrolyte added, some sort of metal here, and wires connecting the metal to a source of electricity. So here's my setup, and it's really quite simple. I've got water with some baking soda mixed in to make the water a little bit better of a conductor of electricity. Then I've got some steel rods I found in my garage. I've got them connected to an alligator clip. I've got a knife I found in my kitchen, and that is connected to an alligator clip. Now I could have used a pencil sharpened at both ends because the graphite would also work like steel. Or you could use a paper clip. Really everything in this experiment I found around my house except for the alligator clips, which I ordered for $6 online. Once the setup is ready, all I've got to do is connect this to an electricity source, which I'm using a 9-volt battery. So I'm going to take the red alligator clip that's connected to the stainless steel rods, connect it to the negative end of the battery, and the black alligator clip goes to the positive end of the battery. And right there, I'm splitting water. But this experiment is brilliant because I'm making oxygen and hydrogen, a little bit of human fuel, and a little bit of rocket fuel. Now before I talk about what's going on the itty bitty scale, let's talk safety. Because hydrogen and oxygen are both very flammable gases. And if you don't use baking soda for the electrolyte, some of the other stuff can give off some pretty dangerous gases. Really, if you do it just like I did it, you should be fine. And this is just like what NASA is going to do on the moon to power the lunar rockets of the future using ice found on the South Pole. And for you curious minds, here's what just happened on the atomic scale. Water molecules were minding their own business, being held together by their covalent bonds. But stronger than those bonds is electricity, which came out of the battery, went down the wire, through the cathode, and out into the water. And this is where the water molecule splits, breaking up into oxygen and hydrogen. And here's where things get interesting, because a hydrogen atom typically has a positive proton and a negative electron. Together, they cancel each other out, making the atom neutral. But when the water molecules split up, the oxygen took hydrogen's one electron, giving it a positive charge. And the hydrogens got pulled to the negative electrode or cathode like a magnet. And the same thing, but opposite, happened with the oxygen. And here they find friends. Hydrogen bonds with hydrogen and oxygen bonds with oxygen, forming H2 and O2, which are now gases. We can take that hydrogen to use as rocket fuel, and the oxygen astronauts can breathe. Now here's a final quiz for you. Identify the other uses of electrolysis. A, used for making aluminum. B, makes pool cleaning products. C, cleans treasure from shipwrecks. D, purifies metals like gold and silver. Or E, is used for making dinner. The answer? All of the above, except for making dinner. I wish. So give it a try at home and let me know how it goes. And until next time, stay safe and stay curious.